Hi everyone. In this class, we are going to discuss about the analog to digital converters. That is nothing but ADC. So these are the applications of analog to digital converter ADC. So here, for example, if you are just like we can take a mobile phone or mic, whatever it may be. Okay, now just you can take as example as mic audio system. So if you are something we are talking something about in mic. So we are this speech is nothing but an analog signal. That analog signal is converted into digital signal. That should be converted into digital signal for the easy transmission and for the modification. So the mic, it consists of a transducer. The mic, it having the transducer, that is nothing but a microphone. So the microphone, it detect the audio signal, that is nothing but an analog signal. That analog signal is taken into the ADC, so that analog signal is converted into digital signal. So after that, digital signal can be stored in a particular transmitter through the CPU or some other data processing unit, and again at the time of delivering into the speaker. So the digital signal is again decoded, again converted into analog signal, and that analog signal will be delivered through the speaker. So that we are in need of analog to digital converters. Okay. So here for the first of all, we have to detect the physical quantity, either the analog signal, that is speech, or in pressure, or in some of the length, or whatever it may be. So any physical quantity that can be converted into the electrical quantity with the help of a transducer. That electrical quantity, it may be an analog or it may be a digital. So if it is an analog, that will be given into the ADC, analog to digital converter, so that it will be converted into analog into digital, and it can be processed by using the digital logic system. Again, the digital signal is converted into analog system, and that will be displayed through the speaker or printer, whatever it may be. Okay, or it may be TV monitor, etc. So here, an analog to digital conversion, it has three types. One is a digital ramp ADC, successive approximation ADC, and a flash ADC. So this is nothing but an successive approximation resistor, analog to digital converter. So here it has a three component. One is nothing but SAR device, successive approximation register, and digital to analog converter, and this is nothing but an operational amplifier with the application of comparator. So here for example, if you are choosing the input, the analog input voltage is 8. If you are choosing for example, we can choose like if you are choosing as a 4. Okay, now the analog input voltage is and 4, and initially this comparator output is 0, and 4 and 0 will be compared. So if both are equal, so the output will be 0, but here both is not equal, so the output will be 1. So that it gives the output is given to the 1 as SAR, so the initially it will be all the 3 will be 0. Actually this is an 8-bit operation, but for the understanding I am taken as only 3-bit operation. So everything will be 0. So if the comparator gives the error signal is 1, the first bit gets enabled. So remaining as it is. So now this information 001 is given from SAR into DAC. So the DAC again it convert the digital into analog. So what is the equivalent value? It will be 1. So again this 1 is came here, and again we are comparing the reference input as well as the present output. So both are not equal. So again we are getting the output is 1, and again the previous output 001. So the 0 is again converted into 0, and again the next bit should be made as 1. So it will be as it is. So what is the equivalent value? Equivalent value will be 2. So the 2 will be taken here. And again we are comparing, again we are not the error signal will be 1, so that the next bit, so here it will be made as 0, it is 0, and here 1, the 1 will be made as 0, and the next bit has to be converted into 1. So what is an equivalent value? The equivalent value will be 4. So again we are comparing the both value, so both will be equal. So if both are equal, the output will be 0. So the process gets stopped, and this output gets displayed. So this is the this is the digital output of the corresponding input signal. Suppose if the input is not 3 4, it is, if it is 3 means whether again it is also not equal, so that, but again we have to compare whether it is less than or greater than, whether it's less than greater than. So here, so the reference is always greater than the present. Now at this case, so again the first bit is 0 and the second bit is made as 1 and the fourth bit is alpha. Okay, so like that we have to change. So it is based on the whether it's less than or greater than. So we have to compare, and based on the error signal we have to enable this operation. So this is an advantage. So the first one, the conversion time is very small, and conversion time is always constant. It is independent of the amplitude of the analog input, whether it's 4 or 8 or 16, whatever it may be. But what is the drawback means the circuit is complex. The circuit is complex. The conversion time is more compared to the flash type analog to digital conversion. This is an assessment in mobile how the voice is transmitted from one end to another end. So you put your answer in the comment section, and these are the few references. Thank you.